Hello and welcome to yet another video of Cornerstones of Math. Today we are going to calculate some areas. Here we have a graph of y equals e to the power of minus x. Then we have these intervals, all having length of 1. Then there are these rectangles, whose widths are all 1 and heights are given as the values of a function at x equals 0, 1, 2, 3 and so on. Then we have these line segments connecting the points on the graph. Here, area A is defined as the area between the graph and the x-axis, starting from x equals 0 and all the way to infinity. Area B is defined as the sum of areas of these infinitely many triangles at the top. And area C is defined as the sum of the areas of these small regions between the graph and the inclined line segments. Let us find the values of areas A, B, and C. First, area A, the area between the curve and the x-axis. This is quite easy since it is given as a simple integral. It is integral e to the power of minus x dx, x from 0 to infinity. This is an improper integral having infinity as the upper end of the integral, and it is calculated by the limit of integral from 0 to c e to the power of minus x dx, where c goes to infinity. So we have limit the antiderivative minus e to the power of minus x, so limit of 1 minus 1 over e to the power of c, which gives 1. Next, area B, the collective areas of triangles. Here, it is useful to think of just one triangle located at the generalized interval x is in between n and n plus 1. Let us call this area Bn. Then we can calculate Bn using the formula for the area of a triangle. This base length is 1, and this length is 1 over e to the power of n, and this length is 1 over e to the power of n plus 1, so the height is 1 over e to the power of n minus 1 over e to the power of n plus 1. Therefore, Bn is equal to 1/2 times base length 1 times height 1 over e to the power of n minus 1 over e to the power of n plus 1, which we can write 1 over 2 e to the power of n times 1 minus 1 over e. Therefore, the area B equals the sum of areas Bn, where n is from 0 to infinity. So we have 1/2 1 minus 1 over e at the front, then sigma 1 over e to the power of n. And this part right here is a geometric series. So using the formula for the sum of geometric series, we have 1/2 1 minus 1 over e. Then the first term is 1, so 1 divided by 1 minus the common ratio 1 over e. So cancelling like this, we have the area 1/2. Finally, area C. As for this area, let us use the subtraction method. That is, area C is given as, first we calculate the sum of the areas of all of these rectangles. Then from that, we simply subtract areas A and B. As for a single rectangle in the interval from n to n plus 1, the width is 1 and the height is 1 over e to the power of n. So we have sigma, the area of a single rectangle, 1 over e to the power of n, and from 0 to infinity. And area A is 1 and area B is 1/2. So again, using the formula for the sum of geometric series, we have 1 over 1 minus 1 over e minus 3 over 2. So e over e minus 1 minus 3 over 2. And if we reduce to common denominator 2e minus 1, then we have 2e minus 3 times e minus 1, which gives 3 minus e divided by 2 e minus 1. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.